experience on integration is almost 6 years. So let me explain you what is this Mule ESB and why we use ESB, where we need basically in which kind of applications we use ESB. And apart from that, I will show you like what is required for our development. Like when you are developing ESB, what kind of knowledge you need to know or before starting any development in ESB. And apart from that, I can show you a few flows, how we'll design flows in ESB. Okay. So before starting, we'll first see like what's ESB. Basically, ESB is in design. Basically, you can say in S4 where each service, like in ESB, everything is a service. Like you can say web services, REST services, messaging services, or HTTP services, FTP services. So everything is a service here. So basically, it's not a kind of a physical entity; it's a kind of framework, you can say, where the services are exposed to the end system and consumed also. Like if you see this PPT, the slide which I shared you, there are 6 systems which are contacting a layer, which is an ESB. So here, each system might be from a different platform, whether that can be a Java platform, a .NET platform, or any other platform like mainframe systems also, or any other APIs like, if you remember, if you know like smart bands, which works on APIs, or your Twitter feeds, if you have seen Twitter API, so where Twitter has exposed some REST APIs to the user developers so that they can make use of them to integrate them into their applications. So these are kind of APIs. And apart from that, we can even integrate FTPs, SFTPs, file systems. So mainly this ESP deals with the different protocols here, like HTTP, TCP, and FTP protocols, SFTP protocols. Okay, so what we do in ESP? So it's like once you get a request inside an ESP, so irrespective of the protocol, it receives a message, and then based on the business, we'll do the transformations. And the end system also here, if you see, are you able to see my mouse? I mean, the pointer?
Yes.
Okay. You can consider this as a database. Basically, this is a data center as per the icon, but consider this as a database. And these are the different end systems which deals with a different protocol. So in ESP, we'll have different services exposed to each system, which can understand by the other systems like Java and .NET. These systems will understand web services. So we can expose HTTP or SOAP services. So that what happens is these services will send information as an XML. And if you consider this as a database, you cannot send that XML directly to the database, right? So what we need to do, we need to transform this XML information where the SQL understands it. Like we need to send an SQL information to that. So how we'll do that? So by making of ESP where we'll extract the data and transform it to an SQL string, and we'll send this SQL string by using a connectors to the end system, which is a database in this case. So it's like a service for any application here. Okay, and coming to Mule ESB, basically before that, why Mule ESB? Like we have different kinds of vendors who are providing ESB. But why Mule ESB? So the main advantage of Mule ESB currently is like for a developing perspective, it's very faster compared to other ESP. And the learning curve also, it's very less if the guy is having some Java background, some technical background. It's not necessary you should have a Java background. If you have a few concepts, like basic concepts of programming, it's very easy to learn new ESP. And you need to understand how ESP works before developing anything. And apart from that, if you look at the product, basically this product as comparative to other products, these are the features of the ESP, which you can see in any other ESP also, but they will advertise it. We are having these features, but these are most of them are common in any ESP, like service creation and hosting. It's like we can create services which I explained you, like we can export the SOAP service, REST service, or any FTP service we can consume. Like if there is FTP, basically is a file system. Generally, we cannot expose it in ESP. We can do only consumption of it. This can be achieved in ESP. And once you develop these services, we can host it in a Mule ESP server or on a Cloud Hub runtime, so that this can be consumed by the external systems. And service mediation is something like something like which actually shields your services within the runtime and do the transformation stuff and all. So the end system don't see what is happening inside. What it can see is in service, which is exposed to them. And message routing. So this message routing works in a different way in Mule ESP compared to other ESPs, where basically in any ESP, message is the main thing. Like once you receive a request in your Mule ESP service, you will get an object called message. In Mule ESP, we'll call it a Mule message. Or in other ESPs also, they'll call it as a message with respect to their ESP. But this is all ESPs will share the same concept of message, where it has payloads, some inbound properties and outbound properties, and few other variables which can be shared across your ESP. Okay. And what is message routing? Basically, message routing is something, if you know any other programming language, where if you span the data or collect the data by using some logic. If you know multi-threading, where a single object can be shared across different resources. So kind of same stuff here, it works. So if you, for example, I'll give a scenario where I got a request from a web service which has a person information. So with that person information, what I need to do is I need to check his age. If his age is more than 20 or 30, I need to route the request to a different end system, which can be some other system where it again reaches the person information and do some operations on it, like it may apply some factors, because we are passing only the person object, or basically in the Mule ESP terms, we are passing person payload, but actually we are passing object of person. And with that person, I can call the end system, where I can get some more details of the person, his background, or his employment information, or any other. And in the same object, by using the same object, I can send another request in parallel to another system, where I can get his bank details. So in Mule ESP, what you can do is, at a time you can pass this information to two different end systems and collect the information from these two end systems, and again you can aggregate the information. So what we are doing here is, based on some information within the person object, we are spanning the request and then joining the data after receiving the data from the end system. So this is called message routing. So there are different types of message routings based on the components in the ESP that I'll show you later. And data transformation. Data transformation is something like, same example, if you take the person object, which is coming from an end system, where before any end system need to communicate to ESP, we need to expose a service in a ESP, our ESP. So if we expose to the service and SOAP ESP or SOAP web service in ESP, so the end system will give us a SOAP request which has a personal information. Okay, and then after receiving this request inside the Mule ESP, what we need to do is we take the same example. We are sending this person information based on his age. We are contacting the third system. What happens if the third party end system accepts only JSON? So that's where this data transformation comes into picture. So in ESP, we have few components like transformers, where by using them, we can transform the data from one format to another format. Okay, so it's like we need to transform this XML to JSON. So by using transformers, we can do that. So the same thing, if you compare these transformation things in transformation components in Mule ESP to the components which are there in other ESPs, comparatively, it's easy in, I don't say it's easy, but the learning curve is very easy for us in Mule ESP. Okay. So there is one component in ESP, we call it as data weave in the latest version of it. And prior to 3.5, it is called as Datamapper. Okay, it gives us a UI where you can do direct mapping and you can write some logic over there to transform the information. So apart from XML to JSON, we can do a lot of transformations like JSON to XML, XML to JSON, XML to Pojo, Pojo to XML, Pojo to JSON, and you can even take that XML, and if you want to store this information to a database, you can convert this to an SQL string. The XML information, you need to extract it and construct a string, which is a Java object again. And we can send this string to the database so that it will get inserted into the database. So these are all called transformations in ESP. Okay. And one more thing, next point is a deploy topologies. This is a differentiating feature if I compare Mule ESP with other ESP. Why? Because the deployment topologies are different here. One you can do, basically once you build a ESP application, you will get a zip file. So this zip file can be deployed into server. So this works in the same way in any other Mule ESP because they have their own formats of archive file which can be deployed. But in ESP, you can, without having this zip file and without having the server also, you can still run it by using the runtime. How it is means, basically the underlying core function of core APIs or like Mule ESP was developed on String based. String and Apache CXF and few other open source technologies it used, and based on this, they had developed this product. So if you have these runtime and you have some web application, you can inject this Mule context into your existing Spring context, and you can directly make use of this Spring, and you can deploy into any web server or application server as a WAR file or ER file. You don't really need a server, Mule ESP server for it. But if your project is kind of enterprise level, a very big project, and definitely nobody is going to deploy this Mule ESP as part of your Spring context because that consumes a lot of memory. Okay. This is the only differentiating feature which I can say compared to other ESP. Apart from deployment topologies, we have connector and API support, which will be available across different ESPs also. So what it is? Basically, API support is something like you can create APIs for any functionality. Say, for example, I can give you, you have some legacy system where you can write some kind of adapters to it by using some programming language. Okay, but how you want to communicate that to any other end system apart from ESP? We don't consider ESP here. How you need to expose this to end systems? If it is a Java application, it's very difficult for us. So we need a kind of service over there which can interact between your legacy system and to the external world. So there also we can make use of ESP by how it is. So if this adapter can communicate, or if this adapter was developed in a programming language where this can be communicated in ESP, then definitely we can put Mule ESP in between this adapter, and then we can expose API. API is nothing but a REST service, you can say. Okay, so we can write some kind of interface where this API will communicate to the adapter, so that it pass the information from a JSON to the object which can be understood by that adapter. That we call it as an API. And connector. This is also the same concept where if you have some APIs already, and you want to reuse the functionality again and again without using the API stuff, or for example, there are some APIs for us. Facebook has some their own API. Twitter has their own API. If you even if you are using Gmail contacts, they have their own API. So how you can use that in Mule? So basically, these Google products or Google APIs will use one common feature called OAuth. So before you do any operation on that API, first you need to get authorized for it. So for these kind of APIs, so once you authorize, they will give a token, and based on that token, you need to do some certain operation on any API. So there are two ways of accessing this. One is through a HTTP call in Mule ESP. Other than that, you can create your own connector, because we call it as a custom connectors in Mule ESP. Okay. So write a connector for that API, which actually takes a JSON or a Java object, anything which can understand in Mule ESP. And inside your connector, you can interact with the third-party API, which can be any other Google API, Facebook, or Twitter APIs. And one of the main factor for Mule ESP is like why it is so popular. It has more than 120 plus connectors. It is more than that actually. So there are n number of connectors which you need to directly connect. Integrate into your flows. For example, Salesforce. Basically, Salesforce exposes some APIs like web services, SOAP web services, REST web services. If you are using some Java application, you need to whether there are 2 to 3 possibilities for you to connect to the Salesforce. One is like using their own APIs, or if you don't want to use their APIs, you can communicate to Salesforce by using their SOAP web services or HTTP REST web services. But what happens if you already have some connector in ESP? You can directly plug and play with it. Directly, you just need to configure the connector configurations where you will provide your username and password, like how we do it in database, where we give the host username and password, and then it will get us the metadata, what all the operations you can perform on each object in Salesforce. That's the main use of connectors in your ESP. So if you already have pre-built connectors available in Mule ESP, so definitely everybody goes for those connectors because it reduces your development time, right? Okay. And another feature of it is SCDA architecture. We call it as a stage event-driven architecture. This is an architecture feature on which Mule ESP was built. Like everything which processing strategies are based off event. So you will have multiple components in your Mule ESP flow. So from one component to another component, it's actually event which get invoked on each component on the underlying stuff. Okay. So what's the use of SCDA? Basically, SCDA works on the concept of event-driven architecture where it is highly scalable and high performance driven. So we'll get high performance if you make use of this SCD architecture. So it was developed on the same architecture, and most of the ESPs are on the same architecture. But if you compare the performance, it depends on the use case, it will vary. But this is one feature of Mule ESP, you can say. And apart from all this, you can say very lightweighted because you can use Mule ESP without a server. You just configure all your configuration files in Mule ESP, which are XMLs, and you can inject these into your existing web applications or any other application. So this can be very lightweighted if you compare with the other ESPs, because other ESPs, like if you say WebSphere ESP, it was built on a WebSphere, and then there is one more layer of ESP for you. And if you go for Oracle, it works in the same way. Or if you go for a WSO2, where they have a complete suite, but if you compare these two, Mule concentrated only on ESP. They don't have complete SOS. But other ESP vendors, most of the vendors, not everybody, they have their own complete SOS suite, and which is very high weighted, like it comes with a lot of resources compared to Mule ESP. So this is a typical Mule ESP application. If you see these are the end system, business application, portals, trading partners, databases, and connectivity services. You can say APIs. So these transport and connectors basically where the protocol comes into picture. Here, this can communicate with HTTP, TCP, or any other different protocols. Databases has their own protocols, and connectivity has REST APIs. And then inside the Mule ESP, you will do this transformation, transaction management, routing, message brokering, and then transport management, security, all these steps. And then these are all you can make you can deploy in any application server or web server, but this is optional, because if you are dealing with a big system, a heavy weighted system, end systems, and definitely we are not going to inject this Mule inside any web application. So why Mule? As I explained, it's a very lightweighted and highly scalable. What do you mean by highly scalable? So it's like if you compare the Mule ESP with any other ESP, for example, I can say WebSphere ESP. So I'm saying why highly scalable. So there's a feature in Mule ESP. It's called auto scalable. So if we implemented any application by using VM connectors inside it, so the data will be automatically distributed across your application, across your servers, not application, across your servers. So which is not which is not going to happen in any other ESPs, because they have designed in such a way. So if you want any high performance by using the servers for your load, you need to have your load balancer before that, so that it can distribute the load based on the each server capacity. So what happens if I exhaust my Mule servers? Can I add one more? Yeah, you can directly add one more instance for it, so that the distribution will happen automatically in ESP, Mule ESP especially. Okay. So one more thing is never lock to a specific vendor. So this is basically an architectural design feature where if you design your Mule ESB flows in such a way that basically there is an option, like if you design it properly, you don't need to stick to the same ESP, even if you remove that and plug it with a different ESP also. So Mule ESP provides such kind of feature for us, like you can easily you can design in such a way that you should not stick with the Mule ESP, but it actually a architectural design. If you design it in such a way that it's easy for you in future, if you want to plug it with a different ESP, you can do that easily. And another feature of it is SCDA. It was developed in SCDA, so it's a normal feature where these ESPs were developed. Fine. And then for a developer perspective, what you need? Basically, Mule configuration files are in XML. So you should have the basic XML knowledge, what is XST and what is XML, how the elements are defined, what are the attributes of XML tag. These are the basic. You don't need much knowledge. You just need to know the basic XML, and you have to understand what is web services, what is SOAP web service, what is the RESTful web services, why do we need SOAP, and what is the structure of the SOAP request and responses and file information. And if you say HTTP, you need to understand how REST works, like what are the methods we can expose in REST web services, and what kind of data we can send in REST services. That also you need to understand. And the basic programming language you need, basically this was developed in Java, so it's better if you have Java. Even if you don't know Java, it's fine because we're not much dealing with Java in Mule flows. But you should have knowledge on OOPS concepts, like how the class and objects and the functions or methods will work. So that is required at least. And if you have some scripting language also other than Java, then it's also very good. Like even you can handle things with Groovy, Python, JavaScript, or Perl, because it provides such components where you can use these scripting languages for you, transformation and all. And finally, you need to understand how Mule ESB works, because Mule has different products like API Manager, and one more thing I think I missed is yeah, here it is. So it has runtimes. Cloud Hub. Cloud Hub is nothing but the replica of your on-premise server. Uh, so that's the same thing. There's it's not different from on-premise server. Only thing is it's a cloud. It's on a cloud. Apart from that, you will have a API manager where you will apply few policies, and you will implement some sort of security mechanisms on API manager before the request routes to your actual application. This happens in Cloud ESB. And you should also need to know what's the API manager and Mule ESB core components, and then Cloud Hub. That's it. And they have few more products. For them, you actually need licenses like Anypoint MQ, Anypoint HF, all these things. But this is like there are very few companies which uses this, so you don't need to worry about it. And apart from this, you should understand how the messaging systems work. Like if you know like JMS or ActiveMQ, RabbitMQ, how these systems works, that will be good actually. So what we'll learn as part of this training, so we'll provide information on how Mule runtime or Anypoint runtime works. Anypoint runtime is the cloud version, we call it as Anypoint runtime. And the API gateway, which I told you, so this is where we use security mechanisms and policies and proxy implementations in Cloud Hub. You can have your own API gateway on-premise also, but for that we need some licenses. Or you can use some third-party API gateway, but we are not talking. And the RAML specifications. So basically, RAML specification is something which you can say a contract will define first before developing any REST service. So what do you mean by contract? So if I have a partner where if we want some API to be exposed, so what I can do from Mule ESB, basically it's not a part of Mule ESB, it's a different specification. What you can do is go to your Cloud Hub or in Anypoint Studio. You can define some RAML file where you can see all the methods you are exposing as part of your REST service. Okay, and you can share this information with your client or your consumer who is using the services. So based on the discussions, you can again change the specification and do modifications and all. So this is just a contract. It's not going to give you anything else. So by using this Raman specification, you can basically it generates a few basic flows for you, but you need to have written your own business logic on that. This is where the Raman is used. And Anypoint Studio is the one which you use for developing new flows. Or if you don't have it, you can download it easily. Or if you are familiar with XML, you can even do XML coding also. But Anypoint Studio is the one which actually gives you the UI representation of the XML for your configuration files. And finally, the Mule components, transformers, and connectors, which are part of the Mule ESB. So these components will use in our flow design, where the actual transformations, connectivity happens. That's all I have. So we have any questions? Hello?
Yeah, hi. Seems everything is good, but one thing is I don't have much knowledge of in web services. Is that web services mandatory for Mule?
It's not mandatory. See, I told you, right? In Mule ESB, we are integrating different end systems. So this end system should not be a web service every time. It can be a database, Salesforce, Workday, any other system. So there's a mandatory you need to have this web services knowledge, but it is good if you have it, so that if you in future if you get some end system which is exposing their services as web services, yeah, it will be good. Like website, you don't need complete knowledge on web services. See, I told you, you just need to understand how web service work. Okay, so generally this communication works in an XML, right? So you can expose a service. Definitely, you're not going to write any XML like SOAP request or define something. You just need an XSD knowledge. That too, if you are implementing some SOAP service in Mule ESP, this specification will be given by your team or the system who is developing that system or who are consuming that system. So you don't need to bother about this. Only thing you just need to know the concept of web service, how it works.
Okay, and one more thing is I just tried to get some free resources on MuleSoft, but it's very tough to get free resources. Is there any way I can get just like material or online sessions?
Uh, no, I'll tell you the documentation which is given by MuleSoft is more than enough.
Okay, no problem. Yeah, and apart from that, yeah, as I'm just talking to people, that they're saying that web services is really mandatory. That's why I have asked whether web services
No,
is.
see, I'll give an example. In one of my projects, I worked with the Salesforce to database integration. So my end systems are database and Salesforce. For Salesforce, I have a connector, and database I already have a connector. So I don't need any web service, right? So
Okay.
it totally depends on what end system you are integrating.
Okay, I got it.
Okay.
Anil, I have a question.
Yeah.
If anybody want to have understanding of web services in the program,
Okay.
how long it may take for them? How many sessions he may be?
It's you're talking with respect to web service, only the concepts of web services, or how to
Yeah, concepts of web
design and
services.
it doesn't take much time. Only thing what you need to understand how you can communicate with the end system. Like if you know, I can say if you know XSDs and XML and how the SOAP request format and the response format and the fault information, that's more than enough for you to do the implementation in Mule. Because you don't need to know how the web service is developed in third-party system. You should know how we can develop it by using those XMLs in Mule.
Okay, okay, Anil. Thank you.
Any other questions?
Apart from me, I'm clear.
Okay.
Hi Anil, like how will be the future for the MuleSoft?
So as per the market, I can say you can still see this kind of market from 2 more or 3 more years. So we cannot predict the future, right? But what I can see is there are very less resources and market is good now. And the way MuleSoft is advertising their product is compared to other ESPs is very good. So we still have a market for 2 to 3 years at least. If there is no other ESP comes into picture and provide better services than this. And this works in a different way. It's not about the technology; it's the way how the product got advertised. Okay.
Okay.
So currently, the market in the market, see why MuleSoft is very big word in the industry is the advertisement is the first one, and the second thing is their cloud support. Basically, other ESPs are taking time to come under cloud because they have complete suite. If you compare it with the Westpair ESP, Oracle ESP, and other ESPs. So, if you compare Mule ESP, they only concentrated on ESP and it's very lightweight compared to other ESPs. That's the reason it's very easy for them to come onto the cloud very faster manner. Okay, so they did the advertisement in the same way. They did it very faster. So that's why people are going to Mule ESP. But there are few competitors like open source competitors for them like WS42 and even I saw like Spring Cloud is also coming, but I don't see future for. I can't say it's a future, but see the way Spring Cloud works, like you need to do a lot of coding compared to Mule ESP, but Mule ESP's thinking is a different way compared to other ESPs. So they are designing their product in such a way that even the developers don't know what is programming language is able to design the and they are making this product as architectural neural by the like version 2 version this is what I observed. Okay, but if you compare the same thing which other ESBs, it's very different. So there's still scope is there for 2 to 3 years easily. That's what I can see.
So what are the other ESBs you're telling like so?
So if you see the open source ESBs, we have WSO2 ESB. And JBoss has their own kind of ESP. And then if you go for a proprietary thing, you can see Westpair ESP, and then Oracle has its own ESP.
Okay.
But there are other open source, but they are not they are not coming to picture in the industries. I'm not sure why it is, but they haven't advertised this. Say like Fuse is also one of the ESP. But it's still the advertisement is very less. But if you compare the feature, it's almost at the same. But few other factors will also come into picture while deciding these ESPs by the companies. One thing is the support, and the factor is kind of licensing cost. Okay.
Okay.
So based on these concepts, they will go for a particular ESP.
Okay. And can I expect like practical training in this session? I mean, like.
Yeah, sure. Basically, this is a demo session. That's the reason I didn't gone into the ID and show. I can show you that. That's not an issue for me. I can show some flows how this will be developed and all. So before opening this, is there any other questions?
From my side, no.
I'm good. That's it.
No. Basically, this is a demonstration. That's the reason I didn't touch on it. So.
So we can call it as it is a tool or else a framework.
It's basically a framework. ESP is a framework. It's not a tool. But you need some tool to design these flows, which we call it as Anypoint Studio. It's the same way how Eclipse works. So this is my simple flow, which I did already. So here I'm reading some FTPs and doing some transformation. I'm not doing any transformation. I think this is a different case where I'm connecting to FTP client and pushing the files to different system. But I can show you that simple hello world program for now.
Okay.
And one more thing I missed is you should know what is Maven also, because this is what we use mostly for building the application. Can I change this? It's a simple HTTP call I'll do now. So we call this HTTP as an inbound endpoint here, where inbound endpoints are the one which actually takes the request. We can say we are exposing this HTTP to the end system. Okay, and I'll show you the payload here. So I told you about the connectors, right? So HTTP has, every connector has its own configurations. If you open that component and click on these configurations, you will get a pop-up where you need to provide basic information about the connector. So in my case, I have HTTP, which I can give the port and base path information here. And if I deploy this, one HTTP service get exposed from this server, from my local server. So I can share this IP information with the path to the end users, saying that I expose this so you can use this service.
In this, can you teach about servers as well?
Sorry?
Can you explain about servers in these sessions? The next session.
Servers means what you are expecting.
On WebSphere.
No, this training is completely on Mule ESB, so I can't show you those. So if you see, got fabric on one side. See, basically, this is our request. Let me show the complete message. Basically, this is a simple request, so I'm not putting any information in the payload. That's the reason it is coming as null. If you want to print something, let me print that first and then show you the message structure. This is a simple printout like in any other programming language. Okay, we call it as a logger component. So you can see the hello world here. This is my first logger, and the second logger I'm printing the complete Mule message here. So as I told you, it has few properties like invocation, inbound and outbound. These are the variable specification, and invocation, if you come into actual development, we call invocation as flow variable, and these are the header information. So you need to understand how the message works in different connectors and payload. So payload, if you see here, because we're not sending any data from the HTTP request, so we will get a null payload. Okay. If you see, this is our request, which we configured in the connector. Try to and the path is test. Is that fine? Hello?
Hello.
Yep. So is that fine, or do you need something else?
Yeah, it's fine.
Okay. So any other questions?
Apart from it, nothing.
Okay, fine. Thanks, sir. Okay. Thank you, guys.
I think we have done with demo, Anil. I'll be closing the session.
Okay, sure. Yeah, thanks.
Thank you, guys.
Yeah, thank you, Shiv.